Hey, fancy boy. This is the review for the mid-quiz on topic 5, systems of equations. All right, so how many solutions do these systems of equations have? It's either one, none, or infinite. So we take a look at this one. These do not cross, so therefore it is no solutions, right? When your lines don't cross, that's all it means, right? Now, the slope for this one is, using rise over run, 1/2. The slope for this one is also 1/2. So hopefully that tells you something, that a system of equations with no solutions will have the same slope. But you can see that they cross the y-intercept at different points. This one at 1, and this one at -4. So they will have different y-intercepts. Okay? All right, so that's your first type of problem, right? Now, right here, you'll see that they cross once, so that is one solution. All that means is the lines cross once, and that's it, right? You're going to tell me what that is. In this case, it's like, I don't know, one, probably 2/3 and 2 1/3, something like that. But you just got to tell me the x, y. We'll go over how to do that on other problems. Okay, now hopefully you can see that there are two lines here: the orange line kind of in the background, and then that black dashed line kind of on top, right? So this situation is called infinite solutions. Basically, it's the same line. Okay, solutions. Now, slope-wise, if I take a look at this, since they're the same line, they're going to have the same slope, right? Slope is going to be -1/3, and then the y-intercept is going to be +2, right? It's the same line, so it's the same, sorry, you can see that right there. So down 1 and right 3, that's the -1/3, and then it crosses at 2, so that's your b value. So infinite solutions will have the same slope and the same y-intercept. Okay, so again, three situations, right? They'll either not cross at all, cross once, or cross infinitely. Okay? All right, now, if I'm asking what is the solution, you're just telling me where they cross. So it's right here, okay? You kind of go down to your x-axis and go over to your y-axis. It's 3 and 1, so your x comes first, so that's 1, 3. Aquí es primero, y es segundo. Okay, so 1, 3. We do the same thing here, right there. So 4 and -2. 4 and -2. Okay. All right, so that's if the graphs are already have the lines on them. You just kind of tell me where they cross. Now, if they don't have the lines on them, you'll have to graph it. Okay, so we're going to start at 1. That's our y-intercept, and then we're going to go up 1 and right 3 right there. I can reverse that to get another point, so my line is a little bit straighter. Instead of going up 1 and right 3, I can go down 1 and left 3. You have to reverse both the rise and the run, otherwise you will not get the correct line. Okay, that's our first one. The second line starts at -2. And then we go up 4 and right 3, right? Up 4, right 3. 1, 2, 3, 4, 1, 2, 3. So we can see that they cross at this point right here in quadrant 1. The x and the y will both be positive here. So that's 4, 2. So our solution, that's an n, is 4, 2. Okay. All right. Similar thing right here. The only thing that might be a little bit tricky right here is this. It doesn't look like this has a slope, but technically, right, it's an invisible one right there, and you make it into a fraction by putting it over 1. So we'll start at -3. Then we'll go up 1 and right 1, up 1 and right 1. So it kind of follows this pattern right here. You don't necessarily have to put this many lines on there, right? Technically, you only need 2 points to graph a line, but the more points you have, the straighter your line will be. Okay, so boom. That's our first one right there. Second one starts at +2, so right here, and then we go down 3 and right 2. We're going down because it's negative. Okay, so down 1, 2, 3, and right 2. So they cross right at that point. That is the point they have in common. That is the point of intersection. A lot of different ways to say that. Okay, and the solution, right, is 2 -1. Okay, 2 is where it meets on your x-axis, -1 on your y. So 2, comma, -1. Okay, just like that. All right, so something like this, we're going to start at -4, and then we would go off the graph down 1, 2, 3, and right 1. So your other point would be approximately right there, but it's off the graph, so you actually have to reverse your pattern. So rather than going down and right, you know that if my line is like this, the other point's going to be roughly around here, right? So rather than going down and right, we can reverse our pattern and go up 1, 2, 3, and then left 1, right? So then let's do another one, 1, 2, 3 here, and then here. So you can see that that lines up pretty well with my estimation. So now we have our negative, sorry, this is 3/1, by the way, as is this. Okay, so, you know, down 3 and right 1. Now for the second one here, that's our first one. We're going to start at +4, and we're going to do the same thing. We go down 3 and right 1. Hopefully you can see that these lines are not going to intersect, so that this is going to be a problem that has no solutions, right? So solution is no solution, okay? Okay, and the reason, right, you didn't even really need to graph it, right? You could see that it has the same slope and different y-intercepts, right? Same slope of -3, but different y-intercepts, -4 and +4. Okay, so really, you didn't really even need to graph this, okay? Different y-intercepts. Okay, the same thing here, right? Technically, we don't need to graph it because we can see same slope, different y-intercepts, so we know it's no solution, right? But let's graph it just to make sure. Okay, so we're going to start at -1, then I'm going to go up 2 and right 1. Actually, I'll do that in blue, but up 2, right 1, just like that. Yeah, that's our first one right there. Then our second one starts at -3, goes up 2 and right 1, like so. Okay, and again, you can see same slope, different y-intercepts, just like in this example, okay? So no solution right there. Okay, this one is a little more complicated because we don't have it in the form of y equals mx plus b for our second equation, so we'll have to convert that. But first we're going to graph this one, start at 3, then I go up 1 and right 3, like that. I'll get another point by reversing it. Instead of going up 1 and right 3, I can go down 1 and left 3, and that's how I got that third point. So boom, finished right there. Now, we need to get the second equation in the form of y equals mx plus b with our x value on the right side, our constant number on the right side, and our y all by itself. So we're going to take this and kind of manipulate it using our, by solving an equation, basically, right? By using inverse operations. So I need to get this x to the right side. It is currently negative, so I'm going to use the opposite, and I'm going to add it. So now I'm left with 3y minus 9 equals 0 plus x is x. As a reminder, that's a 1x, okay? I'm going to take that 9, I'm going to add it, boom, and I get to 3y equals 1x plus 9. You don't have to put the 1 there, but I think it illuminates how kind of your slope hashes out here. So now we need to get the y all by itself, so I need to get rid of this 3 by dividing it, and you got to divide it by both terms on the right, okay? So that 1x over 3 becomes 1/3 x. This 9 divided by 3 is a positive 3. Now, hopefully you can see that when I graph this 1/3 x plus 3, it starts here, and then I can see that, like, if I kind of dash it to distinguish it, I can see it's the same line, right? It's the same slope. So 1/3, 1/3, and it's the same y-intercept at plus 3, right? So this is going to be infinite solutions because it's the same line. Okay? Again, same slope, same y-intercepts. Now this next one, you'd think, oh, this is next. This is also going to be, infinite solutions. It is not. It should be y equals x, not x minus 2, because otherwise the solution will be off the graph. So this y equals x, you can actually kind of rewrite this out, if it helps, to 1/1x plus 0, right? 1/1 is the slope, 0 is the y-intercept. So we know that it crosses here, we go up 1 and right 1 for the slope of 1/1. Okay, I could reverse it, kind of go all the way across if I wanted to, but I think that's enough to give us a straight line. I'm going to just make sure it's lined up all the way like so. Okay. Now again, we want to take this and put it in the form of y equals mx plus b, with the x and the number on the right, and then the y all by itself. So x minus 4y plus 12 is 0. So this is a positive x, so I subtract it. So now we're left with negative 4y plus 12 equals 0 minus x is negative x. Please, a lot of people make this mistake of not bringing that negative down. Okay, if you don't do that, then your signs are going to be screwed up, which means your y-intercept and your slope will be wrong. So then we subtract here. That cancels. I have this negative 4y equals negative x minus 12. Now I got to take this negative 4 and divide here and here. And, you know, as a reminder, that's a negative 1 in front of that x. So that cancels. And then negative 1 divided by negative 4 is a positive 1/4. Negative 12 divided by negative 4 is a positive 3. So our second equation is 1/4 x plus 3. So I start at plus 3, and I go up 1 and right 4. And we get a solution at 4, 4. Okay. So just be aware that you're going to kind of have to switch things around. Like you're going to have to like manipulate equations like this to make it look like that, right? That 1/4 is the m, and that 3 is the b. Okay. All right, last word problem right here. Man, I just love chips. Mr. Wishart bought a total of 20 bags of chips to eat by himself, mind you. Takis cost $2 a bag, and chili Fritos cost $4 a bag. Spent a total of $60. Write and graph system of equations to find the number of Takis, and Fritos that Mr. Wishart bought. So, number of bags of Takis is on our x-axis. X. Number of bags of Fritos is on our y-axis. So first, I'm going to define my variables. X is the number of bags of Takis. Y is the number of bags of Fritos. Okay, again, I got that just from the labels on the axes, right? X applies to Takis, Y applies to Fritos. Okay, now, system of equations means I need two equations. So our first equation concerns just the number of chips, number of bags of chips, right? I know that X and Y represent, Takis and Fritos respectively, and I know that I bought 20 bags. So to represent that, I can just say the number of bags of Fritos, number of bags of Takis plus the number of bags of Fritos equals the total number of bags. Okay? And then the second one concerns the price. I know that Takis cost $2 a bag, and Takis is for our X, so that's going to be 2X. And I know that Fritos cost $4 a bag, and that applies to the Y. And I know that I spent a total of $60. Okay? So now I need to convert these around. This is actually my system of equations right here. Okay? They're both in standard form. So that right there, writing the system of equations is done, really. But if I want to graph it, I need to switch it around to slope-intercept form. So I subtract the x over there, and I get to y equals negative x plus 20. So I'm going to find 20 on my y-axis, and then negative 1 over 1 is my slope right here. Okay. So I just go kind of follow that pattern right there. And then just going to make sure it's lined up like so. Okay. And now I'm going to do the same thing. I take my x value over to the other side. Now I'm left with 4y equals negative 2x plus 60, and I divide by 4. So I'm left with y equals negative 1/2 x, after I simplify that fraction by dividing 2 on the top and the bottom. 60 divided by 4 is 15. So I start at 15, and then I go down 1 and right 2. Down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Give it another one, kind of past the line or a few. Now I can see that my lines intersect at this point right there. Okay. So that point is 10 bags of Takis, 10 bags of Fritos. That's that.